For this type of questions, we can do practical manner, and then this practical manner convert into theoretical manner. In question 4 power n is a natural number. 4 power n, put natural numbers in n. 4 power 1 4, put n equals to 2, 4 square 16, put n equals to 3, 4 cube 64. In this example, given 4 power n ends with the digit 0, but it can't ends with digit 0. Not ends with digit 0. Suppose a number ends with 0, 2, 5 and 10. Because a number ends with 0, 2, 4, 6 and 8. A number divisible by 2. What in the units place? 0, 5. And a number ends with 0. So we can choose this option. We can solve in a theoretical manner. Any number ending with 0 must be divisible by 10. For example, we can do it. LCM of 10. So 2 into 5 is the LCM. LCM of 20, 2 square into 5. So we can say that the number must have both 2 and 5 factors. 2 and 5 as factors. Now look, 4 power n, we can write 4 in 4 we can write as 2 square power n. We can write 2 power 2n. From this we can say that 4 power n contains only the factor 2. It doesn't contain factor 5. Without 5, we can't any number ending with 0. So no matter what value of n we take, therefore we can conclude that 4 power n will never ends with 0. Remember this. LCM and HCF for 6 and 20 using prime factorization method. First do prime factorization for 6 and then do prime factorization for 20 and then find LCM of 6, 20 and then find HCF for 6 and 20. We understood the problem. We can find LCM and HCF for 6 and 20. Let's do prime factorization for 6. 3. So what are the prime numbers? 2, 3, 5, 7. We can do prime factorization using this and do prime factorization for 20. 2 ones, 2 5s. Next 3 is not factor of 5, so 3 is next prime factor 5. 5 ones. Prime factors for 6, 2 into 3. Prime factors for 20, 2 into 5. And then find LCM for 6, 20. LCM means common in both numbers of greatest power. Among this 2 is common in both numbers of prime factors. 2 square is the greatest power, put 2 square. Next 3 power 1 is the greatest factor, there is so put 3. Next 5 is the greatest factor among these numbers, 5. 2 square 4, 3 into 5 15, 15 4 60. 60 is the LCM for 6, 20. Next point, HCF. Common terms in both terms with lowest power. 2 is a common, so put 3. 2. 2 is not pair up, 3 is not pair up, 5 is not pair up, so 2 is the HCF for 6, 20. Solve the. This is the answer. Find HCM and LCM for 6, 72 and 120 using prime factorization method. First, step 1, prime factorization of these numbers, and then find LCM and then find HCF. Prime factorization for 6. Prime factorization for 72. (72) 2 into 2 into 2 into 3 into 3. It also write as 2 cube into 3 square. Do prime factorization for 120. LCM for 6, 72 and 120, which is the common factors. 2 is a common, so which is the highest per 2 cube is common, so 2 cube. Next 3 square, 3. Among these threes, which is greatest per 3 square? 5 is a single term, so put into 5, multiply with 5. Find HCF. HCF means 2 is common in both, but which is the lowest power among this 2 cube, 2 cube? 2 is the lowest power. 2. Next 3 is also common in these 3 numbers for prime factorization. Which 3 is the lowest power? 3 square, 3 is the lowest power, so 3. 5 is not common in both terms because we neglect this 5 in HCF. 2 into 3, 6 is the HCF for 6, 72 and 120. Hope this video is helpful for you. Thank you.